Hi, I'm Debbie Lisk, and I am here to show you the table tennis deep trainer. The purpose of this is to build a device that you can place on a table tennis racket, and you don't actually need a table or the balls to do this, but the purpose is simply for a forehand drive and to learn the proper technique. So when I say proper, it can be different for everyone. There's all kinds of different qualifiers that I won't point out that is documented in my normal documentation. So I just wanted to show the steps. First of all, this is my racket. It's a nice racket with a nice rubber. So I didn't tape anything down or glue anything down. So I've got it bungee corded together here. But this is the IoT or the STM32 IoT development discovery kit. And I'm only using the accelerometer on here for now. But the point of this is to show a good swing, forehand swing, using from the elbow up here. The angle of the racket is what's important as to whether the ball lands on the table or doesn't, or goes into the net. Now, like I said, there's all kinds of qualifiers for this, but in general, you want to have the racket at an angle, something similar to this. If your racket is too open, the face is too open like this, the ball is going to go long. If it's too closed, it's going to go into the net. Now it depends on the speed and all kinds of other things, but the point is we're going to use edge impulse, and we're going to train 30 seconds worth of good, what I would call appropriate or correct swings, then going to record 30 seconds of open swings and then of closed swings. So once we do that, then we'll do a live classification, and I'll show you whether or not I know how to do this correctly. Let me share my screen with you, and I will show you the interface for Edge Impulse. Let me find it. I'll just show you the whole screen for now. Okay, so with Edge Impulse, everything is really, it's fairly simple. Let me hide this, hide floating meeting controls. Okay, so the first thing that we do is we collect some data. So you can go to data acquisition. With this particular board, it's under Edge Impulse already knows about this board, so I can go directly to connect using web USB, and you can see the STM32 is connected there with the ST-Link. So if I connect to that, then I can actually label this as good swings, and I can just maybe do 10 seconds worth for now using the built-in accelerometer. So if I start sampling good swings, I'll wait for it to start. So I got about 9 swings in, and if we look at them, this is what it looks like, and they are labeled as good. So now I'm going to create another label as open, and I'm going to start sampling again, and this time I'm going to have the face of the racket to open. So I'll start sampling. Okay, and I'm going to do it one more time, and I guess you can see this is what that looks like in terms of the accelerometer. And let's do one more time, closed, and do the same thing. This time I'm going to close the face of the bracket. Okay. So we did 10 seconds for each, and that one looks like this. All right, now the next step is to actually go in and to do the impulse design. I think that the window size may be okay the way it is, but we're going to add a processing block of spectral analysis. And I'm going to add one more spectrogram. And I already know this because I've done it before, but I'm going to add just the Y axis because it's important. So what we'll do here is add also Keras classification. And this does have three features, or three output features, and these are the input features. So I'm going to save this impulse. And then I'm going to go to the spectral features. And you can see the window size looks pretty good. It covers most of the important part of the wave. We could probably shift it a little bit, but I'm going to leave it like that for now. Generate the features. And it's doing that now. So job is completed. Then you can see over here, it did a pretty good job of separating the closed, open, and good features or classes. So that looks pretty good. I'm going to go on to the spectrogram, and I'm going to save the parameters, generate features. And we're actually getting close to the point where we can show you the live classification. Okay. Still running. All right, so once this completes, then we could actually look at the model itself. This one's kind of interesting. The classes don't seem to be quite as separate as you would imagine, as the other one was, but that's fine. Because I've done this before, I know that this is good and it does work this way. Now I'm going to actually add an extra layer. I'm going to add another dense layer with 10 neurons. And I'm also going to add a dropout layer so that we don't overfit. And 0.1, I'll just take that as the default. I'm going to move this up here, right here. And we've got three features in our output layer. So we've got fairly shallow deep learning Keras model. So I'm going to train that, and I meant to change this to 50. So I'm going to actually cancel. I'm going to change this to 50 epochs. I'm going to leave the learning rate as it is. You can see the number of features that we have, and I'm going to start training this. When I did this originally, I did it with 30 seconds of inputs. So yeah, 30 seconds worth of training the model for each class. And I'll show you the accuracy that I got for that, but it's pretty close to the same thing. So you're seeing here the 95% validation accuracy in training the model. And this will come up in just a second here and should show you a confusion matrix. I'll give it just a second. model training is complete, and even better this time. So I've I've practiced and I've learned to get pretty good accuracy on to build a model that gets pretty good accuracy. So now the question is, can I do some live classification and prove that I'm learning something? So I'm going to try connecting again. And my device is still here. So I'm going to connect and use the accelerometer, do this for 10 seconds and see what happens. And here's the moment we're waiting for, that I'm waiting for. Okay, so I got, don't remember hitting it that many times. But I guess it can. Okay, so here's the, I wonder if it has the percentage. Interesting. Okay, so over the times that I've done this, I did pretty well. It was uncertain a portion of the time. And this is more than just this one pass. So, but I wanted to show you that you can also get to a point where you can version your model. I have done this in a different one. So I'm not going to do it here. But when you do this and you get to a point where you want to deploy your model, you can actually deploy it into these different formats. And then when you click on build, you'll get your data, your code or your model. So just to show you an example, this is my TableTennisDeepTrainer neural network classifier. So you can see here that it actually stores the data on edge impulse. And you can read in the data and you can see the results here. This was from a different time that I've gone through this. But then you can see that it does a test train split at 20%. It creates the train and the validation data sets. And here's the Keras model. And I think this is the same one that I just used, where I had 20 neurons in the first dense layer, the dropout layer added to prevent overfitting, and then 2 more dense layers, and then that final dense layer with softmax activation, and to get your 3 classes. And then I trained it the 50 times, 50 epochs, and then it saved it to the model, saved the model to disk. There are other ways to look at the data. Let me see if I actually have it here. I don't know that I actually have the code for you to look at. Nope, unfortunately I don't. But you can also generate the C and C++ data code as well. But I did want to end on just this one thing right here that I think is 1 minute of the most important part of this presentation. The audio is not important, so just watch closely. So these people obviously do not need necessarily my device, but hopefully someone would be able to get something, some type of learning out of using this. So I would like to get to a point where I can load everything on here and use the power to power the board directly, and then potentially connect this to the Arduino and connect the speaker so that it actually gives you immediate feedback as you hit it, so that it's like clicker training. Like when you have a dog that you're training and they do something right, you click. And so this would actually click when you do it correctly and you get immediate feedback. So that's the Table Tennis Deep Trainer, and I hope you all have enjoyed it. Thank you.